Okay, we're live. So let me just check some settings on stream. I'm kind of having issues with the YouTube stream. Okay, it is live. Also, I'm not too sure if the music's too loud. Okay, let's start. So I think yesterday I made a list after the stream, and my goal today is to go over stacks and linked lists. So I think linked lists only has one problem. I guess not. Yesterday when I clicked on this, it said the only problem was valid parentheses. I thought that was weird, but which it is, because now there's like a bunch of them. I think it was only for stacks. Valid parentheses, so okay, so the first thing I wanted to do was review stacks as a data structure. Okay, we'll have to look at it somewhere else. But we are going to try to solve valid parentheses. I've also solved this before. So I don't have the solution on top of my head. Like I solved that. I think I solved this maybe a little over half a year ago. I think we could check Leetcode too, but it's been some time now. And I think I've solved it like 2 to 3 times already. So I kind of have a gist of the solution. But why don't we, before we look at the problem, why don't we review? I should probably review stacks. Let's see. I also wanted to get my iPad working so I could like sketch stuff out, because it's really hard to sketch things out on the computer with a mouse. But I cannot get it to work. I think it's because I'm using my phone with continuity, and I think Apple only lets you mirror one thing at a time. Something with it has something to do with the phone's continuity being connected to your laptop and sending that signal at the same time, which is something that happens when you try to mirror another Apple device. So usually I'd have like my laptop connected to my iPad to mirror, to use it like as an external device. And it's not gonna let me do that while I'm using continuity with my iPhone, but I'll figure it out. Because I hate drawing with this. I hate drawing with my mouse. It's like, it really sucks. I don't know how they, I get like what do they call those? Like the Wacom tablets. I could get one of those. I don't see a point of buying that device when I already have practically a tablet. You know, your iPad's kind of something like that. But anyways, let's see. I wanted to review stacks. So maybe where is the best way to find information about stacks? Wait, I have a book. Let me open it up. That way we can look at the same thing. I think it should be here. Okay. This is in chapter 10, page 252. Why don't we look at that? Is it just this part, matrices? Okay. I kind of remember this. First in, first out, property of a queue. Oh, perfect. Look, this is linked list, which is something we're going to go over later for the other problem. Yeah. I think it's just this. So array matrices stacks queues. Okay, I think this is the page that we want. I keep pressing the wrong button. I'm butchering this right now. Okay. It's the wrong thing, dude. I just want to hide this damn menu bar. It's because I have this selected. Wait, that's how you open it? What am I? Okay. Jeez. So where is this part here? Also, why is there like a red line right there? So arrays, matrices, and stacks. Okay, arrays. Should I read that? Stacks and queues. Okay. So I'm gonna read this. And then I'll jot down some notes, and then we could go to the problem. Okay, so I just finished reading the stack section. I'm not too sure if I need to read cues. Just reading this part has me remembering what stacks can do. So I'm not too sure we need cues. We could look at the problem and then like identify if we should come back or not. So let's read the problem and then we go whiteboard. Also, I don't know if you guys could read this. That should be fine. Okay, valid parentheses. You're given a string consisting of the following characters. The input string is only valid if every bracket is closed by the same type of closing bracket. Okay. Okay. Yeah, this makes sense. Let's take some of these and put them on a whiteboard. Okay. Yeah. Okay. So what we can do is we can make two stacks. Because stacks are first in, last out. Essentially, we can check if they're valid by pairing the closing brackets with the last opening bracket. And I think we have to use like what am I thinking? We have to use two stacks, one for opening and one for closing brackets. So we should probably, I really need a drawing tablet. Also, I solved this one before, like a couple months ago. I want to say like over 6 months ago. So I don't think it's useless to do it again, but I think it's almost like cheating because I kind of understand the solution. In my head, I'm just thinking like, we're going to use a switch statement and so on and so forth. But okay, we should probably try to solve it first and then we'll see how good my memory is, I guess. Okay. That's too big. So we can do something like, so for opening, we can place one here and then we can move it. Also, we should look at the constraints. I can't remember. Space is open. maybe we don't need a closing one. Okay, we're just gonna go with both of them because I can't remember if we need a closing one or not. So anyways, we'll have, then this one goes in, then we can move. Also, I'm not gonna keep moving this. Then we have the curly bracket, and then we move, right? So now we're in the closing one. So we could pop off from our opening brackets. And this is where like the switch statement comes into play. So we're just like, okay, our switch statement would have like, this is the closing bracket. If the current pointer is this type of character, we pop off from our opening bracket, and we check if it is specifically curly brace type of closing bracket. And if it is, right, it's still valid, which means we can move on. So then we could process the next. And since we popped this one off, this is like gone. We'll get the next opening. Next closing bracket. And then we can do the same thing. So then we'll pop off. We'll pop off this one, and we'll check that the opening bracket is this type of character. If it is, then we're good. There's like a weird edge case I'm trying to remember. It does not come to mind. I don't know if the edge case comes in when there's like an invalid. I guess we could try an invalid case, and we'll see if that's the edge case I'm thinking about. Anyways, then we'll pop this one off. We get the gist. At the end, this is where you like return true or false. Once you get to the end and this is valid, once you get to and this is valid, we'll check, are we at the end of S? And is the opening bracket, I'm just gonna call it OP, is the opening bracket empty? If this is true, then we have a valid parentheses. Dude, this is horrible to write with. Okay, yeah, I think this is it. I want to draw out the other case, which is like an invalid case. I think we should take an invalid case. Something like this. Because there's like an edge case that I cannot think of right now. But I remember it always throws me off. So let's whiteboard this, a false version. Yeah, let's just do valid. That way I remember what's in here, because then I won't. Okay. And then I guess we can take these two. Also, I just realized I don't think we need the closing brackets. The closing bracket stack. That's what I'm thinking about. we can do without. And so that's what I'm just not gonna copy that one. Okay, I'm gonna kind of, also, why did I draw the arrow on this one, but then there's like an arrow feature here. It's the other way. So, okay, opening bracket. Dude, my settings reset every time. Opening bracket. Then we have another opening bracket. Right? So we move down the line. What? So we move like this. Okay, opening, opening, closing. So we're using like a switch. Also, I can't remember how to implement a switch, so we'll have to look at that. So we do a switch. We're doing a switch on closing brackets. So we'll have like one for closing braces. We'll have one for something like that. Okay, so currently it's pointing at this one. So then in here we'll want to pop from our stack. Opening bracket stack. Dude, it's horrible to write with this mouse. Yeah, something like that. So yeah, we could pop it off. I think it's irrelevant if we just peek at it, because we'll have to remove it anyway. So we might as well just pop it off. So we can do pop, and then it'll be like, we'll get this character, right? And we could check if that character does not equal its match, then it's false. We could return false. And in the case that it's true, we just don't do anything. I think it's that simple. And there's another case. Okay, there's a case where you start off with closing. I think that's the one I was thinking about. Wait, why is it doing that? Okay, grab this. Okay, let's kind of walk through this, one of these. I'm not gonna take the writing. That's kind of weird. Okay, so for closing, you can't start off with closing. That's just like the main, that's one of them. So if you have a closing one, you just check your stack. I think it's the same type of check we do for the end, I think. So we're kind of doing this. If let's say I is our index. So if I equals 0, we know we're at the beginning. And we can check if I is equal to 0 and we're gonna call it OP. I think that's what we said earlier. Yeah, if it's 0 and OP is empty, return false. Wait, no. No. If we're at the beginning, our opening stack is empty, and the character and S is equal to an opening bracket. I don't know if we have to catch this. Does the switch statement catch this? Also here, I think that's what I'm working with. Before the switch statement, you'd want to push the opening brackets. So you'd do something like do you do another switch statement? What do we think? Do we do another switch statement, or is it just a really long switch statement? Okay, I think we might be ready to implement it. The coding part's a little weird. Yeah. Okay. Also, I should have started the timer. Should I do a stopwatch to see how long it takes me, or should I do a timer? Okay. I can try to do... I guess I'll do a timer. I'm gonna do 20 minutes just because I think I spent about 20 minutes trying to whiteboard. But let's just move on to try to implement it. Okay, 20 minutes. We'll see. Okay, off the bat, I think, how do you do a stack? Do you just do a vector? Or is there a, let me see, C++ stack. Is there an example? Okay. So I'm gonna call it S, but I'll comment it on here. This is too zoomed in. Okay, we'll have a stack. We have to iterate over S. That's the other thing I don't remember. I know you could turn this into characters, I think. So you could iterate through. Why don't we just try it out? So can we do this, or we have to convert S into characters? I think I've used toChar before to iterate through a string, but I can't remember. You can just iterate like this. You could access them like an array. That's kind of weird. But does that also mean I could just do like, I mean, yeah, that's what it means. Wait, I just realized I should not name it the same as a parameter. I'm gonna call it OP. That's what we have on the whiteboard. I'm assuming we can do this too. If it's treating it like an array. I used the wrong thing up here. Okay. That makes more sense. Okay, what's next? What was... Is it a switch statement for every type of bracket? Wait. Okay, I have it in my head. C++. Okay, wait, I'm gonna take this. Okay, so we grab the character, and then if the character and I think there's only 3, right? So Then we're gonna push them to the stack. I think it's push. I have to look that up. There's a move version. What do you mean? Okay. Yeah, we just push it onto the stack. Is there a default for this? So we push and break. Wait, I think we could do it all under the same thing for the for the closing brackets. Can you format? So we want to check if, let's look at the whiteboard again. I think this one was great. Wait, are we running out of time? 10 minutes, okay. So we already did this part where we push all the opening brackets to the stack. And then the second part is once we get a closing bracket, we want to pop from the opening bracket stack and compare them. If they're not equal, then we could return false immediately. And if they're equal, we could just continue. So I think we just break either case. Or, sorry, we break. Where'd it go? Yeah. So if op.pop is it called pop? Yes. It returns top element from the stack. What is this? In place. Okay, doesn't matter. We can just pop and compare. If it's not equal to this character, we could just return. And then we could copy and paste this for each one. That's the idea. We just have to change that they match the brackets for the switch. I think we can add like we want to check that the stack is not empty. Oh God, what was that? Wait, I just seen empty on there. I don't know why. It returns true if it's empty or false. Okay, I'm like in my head. So we want to make sure that if the beginning of the string is a closing bracket, we want to make sure that the stack is not empty. That doesn't really make sense now that I'm thinking about it. It would. Oh, we can also say like, instead of this, we could just check that I is not equal to 0. And we can just repeat this. So if we meet a closing bracket at the beginning, we check, well, are we at the beginning of the string? If we're not, then we can pop and compare. Yeah, I think that makes more sense. Okay. I'm trying to think. Once it gets to the end, do we have to check anything else? Oh, right. I think if the stack is empty, what was that? I think that's it. Wait, there's an... Are we supposed to use this? Okay, what am I missing? Let's use Neetbot. Let's see what it says. Oh. Wait, that's what I wrote before. I don't think that's right. Oh, you don't do -1? Okay. Okay, this one's fine. We can replace that. Okay. You do the pop after. Okay, I'm gonna dismiss. Wait, we want to accept this one. Sorry, it was. I'm gonna dismiss that. Accept that. Accept that. We can accept that. What is this? Yeah, we can delete that line. I'm confused. I thought pop gave you the number 2. It just removes it. Okay, we have 7 seconds. I'm practically done, so I guess we could just stop it, and submit. Okay, let's use our last fix, I guess. Wait, so what was I using? Wait, this does make sense. So if it's a closing bracket and the stack is empty, then we return false. What I was doing was, if it's a closing bracket and we're at index 0, meaning we haven't processed anything else, then we can return false. It's kind of, it's technically the same thing. This top part's kind of weird. Why isn't that one working? I had already done the pop, did I not? Let's see, you can close that. How do you pop that damn hint up? Generate, okay, wait. We'll take, it's just this part that is changing. False, and we pop. Wait, this one's. Okay, we did it. Wait, I should submit. I don't know if it'll pass. Nice. That only took 40 minutes. Okay, it's O-van. Should we use this? Yeah, it's O-van. Does it have, so space is O-van. Yeah, because we only use one stack. Okay, I'm gonna take a break, but I'll be right back in a bit. Okay. So, what are we doing next? Oh, also I wanted to check. It used empty, but I wanted to know if it would work with my solution, which was, it was this. Wait, also I think this is how I had it. I just want to check this real quick. If this doesn't work, then that's already like, it's another thing I did not account for. Oops. Wait, why does it fail? Okay. Yeah, I think this must be included. Okay, we'll keep it like that. And we should move on. The next one is linked lists. So let's open this one. Okay, it was right underneath what we were reading. So okay, so I'm gonna read this section on a linked list, and then we could look at the problem. I think, is it 1 or 2? Can't remember. It's just 1. Okay. Okay, I don't know if I have to read the rest of this. I think this first paragraph kind of gives the gist. Even the first figure. So this one's doubly linked, so we could point to the previous node and the one after. The head has no previous, so it's not circular. And the tail has no successor, so there'll be null. So if we're at the end, if we try to do next will be null, and that's how we know we're at the tail. Also, L head points to the first node. Then we can do then we know that the list is it's empty. Sorry, if L head is null, we know that the list is empty. And circular list or circular linked lists is just when the head's previous points to tail and the tail's next points to head. So you could do like L head dot prev, which will give you this one. It'll give you one. Do we care about insertions? Okay, we could look back at this depending on the question. So I think what I want to do is look at the question itself. So the question is reverse linked list. It's singly linked list. Okay, what's the question? Given the beginning of a singly linked list head, reverse the list and return the new beginning of the list. Okay, this one's like weirdly correlated with the stack. So we can iterate through the list, grab each element and put them in a stack, and then generate a new list, and then pop off the stack with these values, and we'll get them in reverse. And then we could just return the list node, the head, I think. I don't know. Is there another way to do it? Let me think. Why don't we whiteboard? That's a good idea. So let me grab this. Okay, so what I'm thinking about is we can get a stack Also from the diagram, we would have, this is what it should look like. There's 4 of them. How do you grab, is there a shortcut for this? Okay. So then this one would have 0, F1. Cool. And what I was thinking was we can have a stack. We can iterate over the linked list and then grab each value and push them onto a stack. Like that. And then what we can do afterwards is we could generate a new node. There's got to be a different way to do this. Then we could like pop stuff off the stack and fill in the node, or fill in the value for a new linked list. I don't know if this is optimal. Okay, it's non-circular, so we can't go like previous. It's a singly linked list. Okay, I'm trying to think if there's a different way to do it. I don't think there is. I think this is... Unless there's a way to like move the way it's... I don't think there's a way to like change next in a meaningful way so that we reverse it. Okay, I'm gonna go with the stack. It might be that one just because we just went through stacks. It was also an easy one. So we're gonna include stack. Wait, do we, okay. Before we try to implement, can we do a stack of like nodes? I don't know how valid this is. If this doesn't work, I should just do the int. No, I think I should do that. Okay. And then I think we can iterate over okay, we could iterate over the list. So we could say like, wow. Wait, is it head.next or is it? How do you iterate over a list? Okay, we can look that up. I know you could do next to grab the next value, but how do you do that until you get to the end? That's what I'm not too sure. Okay, I think this is not helping. Okay, so you make a node, you set it to the head, and while it's not a no pointer, actually open the whiteboard. So we wanted to push the values onto a stack. And then when we pop them off, we want their next let's just make them values. Yeah. I didn't put the timer. We'll just do a stopwatch. Okay. So now we have the stack. Then we could iterate over the stack, which would give us the values in reverse. Yeah, we could do like cannot type that. Do I just initialize it to 0? Wait a minute. So we want to, okay, make a new node. Then we want to set the node's value. We also want to do we want to set the nodes next. I don't think this makes sense. We can do, technically we can do this. We can also pass in the value. Wait a minute. I'm stuck on this one. I don't know how to make one. Okay, I think I got it. I think this is what I'm looking for. So we want to insert at the end. like super small. I cannot read that. Okay. Maybe we should watch a video.
Are you Marsha?
I am.
Have the advantage. Here's a representation of a linked list. A linked list is made up of a long chain of nodes. Each node contains two parts, some data that we need to store, and an address to the next node in line, also referred to as a pointer. Linked lists do not have an index the same way that arrays do, but each node contains an address to where the next node is located. So these nodes are non-contiguous. They can really be anywhere within your computer's memory. If our initial node has a memory address of 123 Fake Street, like our array example, then the next node in our linked list could have a memory address of maybe 101 Help Boulevard, and another could be 404 Nowhere Lane, then 666 Crime Circle. Each node knows where the next node resides. I imagine this as if we're following a scavenger hunt or a series of clues to find the end of the linked list, the tail. Each node has an address, a clue as to where the next node is. We begin at the head and work our way towards the tail, following each clue, each memory address found in each node. Then we know when we reach the end of our linked list when we check that address, our pointer, and it has a value of null. That means we're at the tail, we're at the end of our linked list.
This makes sense to me. I
Inserting a
just don't
node is
understand
easy
how
in a
do you
linked
actually
list. There's no shifting of elements involved. Wherever we need to place a new
insert.
node, we take the address stored in the previous node.
So if we do, okay, we can create the head to be the current value at the top of the stack. So here we can do node stack.top, and we could then just pop. Okay, so that's technically our head. Result. Oh, no, what I do? Okay. Oh, I see. Wait, why is it doing? Okay, this makes sense. We should also check that the list is not empty. Check. Is it just dot next? So the head is no. Okay. So we set the head to the top of the stack. Then we can start iterating. Maybe this is not a good iterator for this. Wait a minute.
Node and assign the address of our new node with the address from the previous node so that our new node is pointing to the next node in line. Then we can take and replace the address in the previous node with an address that points to our new node. It's as simple as that, and we're completing our chain simply by inserting a node at a given location. There's only a few steps involved, no shifting of elements required. Deleting nodes are easy too. Wherever we need to delete a node, we have the previous node point instead to the next node in line. Again, no shifting of elements is necessary. Now, this is where linked lists tend to be inferior to arrays. They are bad at searching. We can randomly access an element of an array because we have an index. With a linked list, that is not the case. To locate an element, we need to begin at the head and work our way towards the tail until we find the element that we are looking for. This itself takes time. In fact, it would take linear time, but making the insertion or deletion of a node is constant. This variation of a linked list is a singly linked list. There are single links to each node. However, there's another variation called a doubly linked list. A doubly linked list requires even we need to. Some will throw exceptions, some will return a special value, so you can use any combination of these really. And not only do we have these 12 methods, but we can treat our linked list as either A, B, C, D, F. A is at the head, F is at the tail. And to remove the head of our queue, we do not use pop, we use pull. And A is no longer in here, we have B, C, D, F. So you can use a linked list to mimic a stack or a queue. Before we move on to the next section, I'm going to get rid of this pull method. So we have a typical grading scale, A, B, C, D, F. Where linked lists are really good is the insertion and deletion of nodes. Let's say for this example, I need to add a node between D and F that contains the letter E. So that's really easy to do with a linked list. We would type the name of our linked list, dot add, list and index.
Okay. Let's undo this. I think I've taken over 30 minutes. So what I'm gonna do, I don't want to look at the solution just yet. What I want to do is I'm gonna ask chat to see if it can like give me an idea at least of how to add new nodes, because that's where I'm stuck at. I don't know how to add new nodes to the list. I created the head, the results head. I don't even know if that's right either. But if I have the head, I could loop. What I want to do is I want to loop through the stack now and then put these new nodes and attach them to the head or something along those lines. But I'm not quite understanding. Well, I don't understand the explanation on the videos. Okay, yeah, let's do this. We could try one of these. Okay, my question is, I don't need it to like solve it for me, so I'll just say that. Okay. I'm stuck on creating the resulting to be returned. I should just give it the code. Okay. Let's see if my computer's fast enough to do this. Kind of don't want to use ChatGPT or anything like that. The video made sense. So that's kind of what I read in the textbook, which was you can access the next value by using .next, and then if .next returns null, then that's how you know you're at the end. But I'm not quite sure how iterating through them works, and then inserting new nodes. That's kind of, if I'm so used to doing arrays that this doesn't really make sense in my head. It's gonna take a while, isn't it? I think I had a pretty good. This is valid, I think, which catches example 2. What is this? Recursion, linked list. I'm assuming, oh, yeah, so mine's is not optimal for space because I'm using a stack, but it's just to be O of n, which is, my solution would be worst. But we could come back to try to solve it in constant space. I just kind of want to get this solution out of my head because I feel like this is not optimal, but it does use the stack, which is something we did previously. And I think it'd be good to like use that just because it's new in my head. And it's kind of weird because like I get to apply it to a different question that has nothing to do with stacks. It's not even, stacks not even part of the topic, it's recursion. But yeah. Is he like getting himself into circles? What's going on? I think he's confused. Dude, my fans are running like crazy. Can it answer this? This dude's like going in circles over here. I don't even think he knows how to solve it. Okay, we're just gonna stop it. Yeah, I'm gonna stop that, and we'll just use like a my computer's like super hot. I think it just got confused. I think that's. It kept like trying to solve the problem. Okay, what's going on with this? So the main issue isn't tying nodes to the new head. So your current structure never advances through the list, and it also doesn't maintain a pointer to the tail of your new list. A couple key problems to fix. So you never do current is equal to current dot next, so it would never loop forever. Wait, so it will loop forever. Okay. Right. Stack is not iterable. I was trying to iterate over a stack. Yeah, I think what I was supposed to do is node stack. Yeah. That makes more sense. What's the other one? What does it do then? It doesn't allocate a node. You need a pointer that keeps track of the last node in your results so you can keep chaining. Every time you create a new node from the stack, you allocate it, attach it to next. Wait a minute. So we're gonna create a res head. Every time you create a new node from the stack, you allocate it, attach it to the tail, and move the tail. So you have res head, node 2, node 3. Okay. Okay. Right. Wait a minute. I could do this, and then I could do node stack. Is this gonna work? Wait, why is it 0? Oh. just return can it just return head since it's already empty? I think there's probably some other edge cases. Oh, okay. Yeah, this is not optimal. And also, I struggled a lot in filling the list, which is, I think it's something I didn't need to do. I'm assuming they somehow move the way the nodes point. So like, for example, at the tail end, it points to null. But I'm assuming they're doing something where you could change the pointer to its previous to the previous node. I'm guessing it has something to do with that. I need more time to think about it. I'm really not sure how you would do that. Also, it has, I think there's like a recursive solution. We could look at the solution now since we already solved it. But I thought this was interesting. We could use the stack. It was very convenient since we just solved the other problem with it. But we could take a quick look at solution to see. I'm assuming maybe my solution has to do with like worst case. Oh wait, he does recursion for the first one. Wait, he just does the recursion. Wait. So recursion, and then what's the other one? Iteration. Reverse analytics. The curve is all about flipping pointers. This is what I was thinking about. Okay. This from left to right, and for each node, we redirect its next pointer to the node behind it. That makes more sense. To avoid losing track of the rest of the list, we keep 3 pointers. The current node we're processing, the previous node, that should come after. What? The node that should come after current, once reversed, the original next node, so we don't break the chain. A few pointers forward. Each step we gradually reverse the entire list. When current becomes null, the list is fully reversed and previous head. We initialize previous to none and current to head. Node with value 1. Enter a while loop since our current is not none. Store current.next into a temp variable. Reverse the link. Current.next now points to previous. Previous to current. Previous, current, you iterate with current, and then a new node that's equal to the next node of the current. You set the previous node to equal the current node. You set the current node to equal the temp node. Okay. We'll come back to this eventually. I feel like an easy solution would not have been, I mean, maybe it's easy to someone, but what is the recursive solution? This is very interesting. Okay. We'll stop there. Why don't we see what we can do tomorrow? I think I need to learn more about linked list. The quick review I did is not enough. Weirdly enough, the visuals don't really help. I'm really not sure what could help me understand linked list better. Like, I get the overall concept. I'm not too sure, like, traversing them. That was my problem with the question we were doing. I guess I could do just try to complete like this section, and then we can move to these. Yeah. Okay. Sliding window. I like sliding windows. Also, I've been doing a bunch of easy, so like I say I like sliding windows, but then like let's see this one. Then I'll say like, oh, I hate it. You mean assume that the correct output is always unique? What is the answer? So we have X, Y, Z. Wait, what's time complexity? It's linear. YX AZ is the shortest substring that includes XYZ. Okay, we'll stop here. I think next we'll go back to stacks. Min stack. We'll do min stack. Let me add that to my notes. So let's see. not working? There you go. Yeah, we'll do min stack. Should we just do a bunch of, I think I could do a bunch of stack ones. We'll do 2 stack ones. So we'll do min stack, which is a medium. Yeah, we can stick with mediums for now. Min stack, and then daily temperature. I think those 2 are good for tomorrow or next time. But for today, I think that's all. And then we'll do some more next time I get on. All right.